Fourth grade lesson 5.3 is problem solving common factors. Now that we've learned that factors are the pieces, the numbers that multiplied together will give us a product, we're going to start recognizing that finding common factors is a tool we can use when we have different amounts of something, but we want to represent them in an equal way. We can find their matching or common factors to help us do that. And there's occasions where that happens and you're surprised by the fact that, oh, I need to do this. What tool can I use? And sometimes people forget this is a tool in your toolbox that you learn that you can use this skill. So let's go ahead and learn the skill, and that way we have that tool in case we need to use it. The essential question is, how can you use the make a list strategy to solve problems with common factors? So we're going to see a problem in the unlock the problem where knowing the tool of common factors between two values is helpful. Chuck has a coin collection with 30 pennies, 24 quarters, and 36 nickels, so 3 different types of coins. He wants to arrange the coins into rows. Each row will have the same number of coins in them, and all the coins in each row will be the same. For example, all the coins in the row will be all pennies, or they might be all nickels, or they might be all quarters, but they won't be a mixture of pennies, nickels, and quarters all mixed up. How many coins can he put in each row? The information in the graphic organizer below is going to help us walk through how to solve a problem like this. All right, I need to find how many coins will be in each row. So how many coins that can go in each row so that each row has an equal amount, the same number of coins in each row, and all the coins in the row will be the same. I'll underline that. And kind of abbreviated that, same number of coins, all same type of coins. What information do I need to use? Well, I know what he has. He has 30 pennies, 24 quarters, and 36 nickels. I'll circle that information. So each row, a check has 30 pennies, P for pennies, 24 quarters, 36 nickels, and each row is going to have an equal amount, same number of coins, all the same coins. Same number of coins, all the same coins. How can I use this information? I can make a list to find all the factors of 30, 24, and 36, and then I can use the list to find common factors, because it's those common factors, the factors that are the same, that is going to tell us in which way we can make those rows in the way they want us to. When you're trying to make arrays or rows or something that is similar, when you have a different value of things, that common factor skill is the tool that you use. So I've put on here 30, 24, and 36, 30 pennies, 24 quarters, and 36 nickels, and they have those here for us. I'm going to write them underneath here, but bigger, so I can work in a bigger way. I like to have lots of room for my math. And I'm going to use that T-chart for my factors the way I was before. It's what works for me. Hopefully it makes sense for you too. Let's start with my factors of 30. I know that 1 times 30 equals 30. I also know that 2 times 15 equals 30. 2 15s equals 30. 15 plus 15. And I know that 3 times 10 equals 30. Okay. 4 times nothing equals 30. But 5 times 6 equals 30. And then the next number is going to be a 6, right? But there it is. So now as soon as I've hit that point, I can just curve around. These are all the factors of 30. Let's do the factors of 24. I'll do them in blue. 1 times 24. That's hard to see. Let's do this blue. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. 5 times nothing. No, 5 doesn't go into 24. And now I'm back at 6 again. So back up. These are all my factors of 24. Hopefully you're starting to see how you go about getting those factors. Let's do 36. 1 times 36 is 36. 2 times, I think it's 18. Let me just double check. 2 into 3 goes once. And 2 into 16 goes 8 times. Yes, 2 times 18. 3. Yeah, that should go. 3 goes into 3 once. And 3 goes into 6 twice. 3 times 12 is 36. 4 times 9, that's a math fact that I know, is 36. 5 times nothing is 36, because to be divisible by 5, we need to end in either 5 or 0, and 36 doesn't. 6 times 6 is 36, and then there I am at 6 again, so then it's the way back up. So once you hit that next number, then you just head back up again. So here are all my factors. Okay, I'm going to go through and circle in this bluish color the common factors. These all have 1. Every product has a factor of 1, which means I could technically put all of these coins in one row with 1 in each row, and that would satisfy the requirement. Same number of coins in each row, 1, and all the same coins in each row, penny, 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 penny. But that would be a whole long set of things, right? Okay. Next common factor is they all share 2, 2, 2, and 2. So I could, and have all equal rows, I could put 2 pennies, 2 pennies, 2 pennies, 2 pennies, 2 pennies until I run out of the 30 pennies, and then 2 quarters, 2 quarters, 2 quarters until I run out of the quarters, and then 2 nickels, 2 nickels, 2 nickels until I run out of 36 nickels, and I would have it perfectly lined up, following the rules, same number of coins in each row, all the same coins. So that would work because they're common factors. That's what that common factors is showing us. Do they all have a 3 as a common factor? Yes, they do. 3, 3, and 3. So I could put them in rows of 3 and it would work. I would not be able to put them in rows of 4. While these share, this one doesn't. So rows of 4 won't work. Row of 5 won't work. Row of 6. Ooh, I could do rows of 6. That would work because they all share that common factor. So I could do 6 pennies, 6 pennies, 6 pennies, 6 pennies, 6 pennies until all 30 were used. And then I could do 6 quarters, 6 quarters, 6 quarters until all 24 were used. And then do the same with nickels, 6 nickels, 6 nickels. They would have the same number of coins in each row, 6. All of the coins would be the same. Pennies, 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 quarters, 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 like that. That's what we're trying. That was the goal that we were trying to reach, and finding common factors is how you do it. What about 8? No. 10? No. 12? I'm seeing 12 over here. Well, let's go to 12. No. 15? No. 30? No. No, it looks like the largest amount that is shared is 6. By the way, that's called the greatest common factor, the largest common factor. Greatest common factor is something you'll use in math a lot. You'll hear it referred to as GCF, greatest common factor. It just means the largest value of the shared factors, the common factors. GCF, greatest common factor, in this case, for these 3 numbers is 6. It's the largest number that all of these share. This lesson is just about common factors, all the rows we could have done for this scenario. 6 is the largest of them, but these were all common factors. Common factors are 1, 2, 3, and 6. 1, 2, 3, and 6. So we could line them in one coin per row. We can line them in 2 coins per row. We can line them in 3 coins per row, or we can line them in 6 coins per row and meet all of the requirements this problem wanted. Let's look at another example because it's going to help our brain see, like, in what scenario do I need to make common factors to help me out. So let's look at another one. Ryan collects animal figures. He has 45 elephants, 36 zebras, and 18 tigers. He will arrange the figures into rows. Each row will have the same number of figures, and all the figures in the row will be the same. Similar to the last question, right? how many figures would he be able to put in each row to satisfy his requirement of the same amount or of figures in a row, and in each row all of the figures would be the same, either all elephant, 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 or all zebra, 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 or all tiger, 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 tiger. We'll use the graphic organizer below to solve the problem. We need to know how many rows and how many will be in each row if to keep them all the same figure. So I've written here we want the same number of figures in each row. If there's 3 in a row, 3, 3, 3, 3, and all the figures in each of the rows will be the same. What information do I need to use? I need to use the fact that he has 45 elephants figures, 36 zebra figures, and 18 tigers. 45 elephants, 36 zebras, and 18 tigers. That's a 6. Let me make that neater. How will I use that information? Well, when I'm trying to take a different amount of each item, but I want them to be grouped in a common way, the tool I use and pull out of my toolbox is common factors. So that's what I'm going to use. I'm going to find common factors, and that will tell me how I can split those. So I will take the numbers 45 and find all of his factors. I will use 36 and find all of his factors, and I will use 18 and find all of his factors, and then I will find out which factors are shared. So we have 1 times 45. 2 won't work because this is an odd number, not an even number. Good to know that, right? So we don't have to work hard to find it. 3. Will 3 work? Well, let's use that divisibility rule with the 3's. 4 plus 5 is 9, and 3 does divide equally into 9. So 3 will divide equally into 45. I just don't know how many times. So let me just kind of go off to the side here and do my division real quick. 3 goes into 4 only one time because 3 times 1 is 3. 4 minus 3 is 1. Bring down the 5. 3 times what equals 15? 3 times 5 equals 15 exactly. And we knew it was going to be exactly with no remainder because we know that 3 divisibility rule. So the answer is 15. 3 times 15 equals 45. What about 4? No, because it's not even. 4 goes into even numbers. 5, yes, 5 will work because it ends in a 5, and I know that 5 times 9 is 45. What about 6? No, 6 has to have something about even numbers. What about 7? No, 7's not going to work. 8, no, 8's not going to work. And then I'm back at 9 again. So these are all the factors of 45. Let's do the factors of 36. 1 times 36. It's even, so I know that 2 goes into it. I think it's 18 from the last problem. I think I remember it was 18. 2 times 1 gets me as close as possible to 3. I get 1 left. 2 times 8 equals 16. So it's 2 times 18. 3 times 30, or 3 into 36. I think it was 3 in the last problem, and then it was 12. 3 times 12 equals 36. I know that 4 times 9 is 36 because I have that memorized in my math facts. 5 times nothing is going to give me 36 because 36 doesn't end in a 5 or a 0. And then 6 times 6, I know because of my math facts, equals 36. And there I am back at 6 again and back up. Okay, 18. 1 times 18. You get faster at this as you go along. 2 times 9 is 18. 3 times 6 is 18. 4 times, yeah, 4 is not going to work. 5's not going to work. And then I'm back at 6, so I can stop because now it's just trending back. Let's find all of our common factors. Now that we have found all of our factors, let's find all of our common factors. We know that 1 is going to be a common factor. It's always going to be a common factor, but we're pretty sure Ryan doesn't want to do rows of 1 forever, like all of those in rows of 1. That'd be a bunch of rows. Could he do a 2? No, because this one doesn't have a common 2. 3, ooh, yes he could. He could do rows of 3. and meet the requirement, there would be the same number of figures in every single row, and all of the figures in each row would be the same. That would qualify. Could he do rows of 5? No, this one does not have a 5, nor does this one. 6. These have 6s, but this one doesn't, so that's out. 9. Oh, yeah. 9 is a common factor for all 3 numbers. He could do rows with 9 in each row, and he would satisfy that all the rows would be 9 when he got done, and each row would have the same number of, or would have the same item in each of the rows as everything else in that row. Anything else? 15, no. 45, no. Yeah, that's it. That's the only match. So the largest amount of rows he could do is 9. That's the greatest amount he could do to satisfy the requirement. That would be considered the greatest common factor, the GCF. But again, in this lesson, they're just asking how many possible ways he can do it. They're not really making us narrow it down to the greatest common one. Our common factors are 1. Oh, I want a better color for that. 1, 3, or 9. That's his options. He'll probably choose the 9, so he doesn't have to have so many rows, but that's how you do it. So I know we're not usually putting things in rows like that, so you're like, why would this be a useful tool? But this is also useful. This skill is also useful for, let's say you're putting together gift bags for people, like maybe gift bags of candy, and you have 45 Red Hots and 36 Reese's Cups and 18 Twix, and you want to make sure that everybody gets a fair share of each of those, right? If you want those bags to be split so that everybody's getting the same amount of Reese's and same amount of Twix and same amount of Red Hots as each other, then you would use this tool. You would say, okay, well, how many of each kind can I put in there? Or how many groupings of this can I put in there? Greatest common factor is how you would do it. Okay, if you feel like you're ready to try it, you can pause here. If you feel like you need me to walk you through this one a little more, that's okay too. Lucy has 40 bean plants, 32 tomato plants, and 16 pepper plants. She wants to put the plants in rows with only one type of plant in each row. All rows will have the same number of plants, all that same sort of idea that we were working on before. How many plants can Lucy put in each row? First, we would read the problem and think about what we need to find. We need to find that same amount of rows and the same type of plant in each row, same as we did with the coins, same as we did with the animal figurines. How will we use the information? We're going to find all of the common factors. That's what we learned in the lesson. And that would tell us how many rows we can do. So we would make a list, find the factors for each number in the problem, and that's what we're going to do. And then we would use the list and circle the common factors. So let's do the list over here. We have 40 bean plants, 40, 32 tomato plants, and 16 pepper plants. And we're going to find each of those numbers factors. 1 times 40. 2 times 20. Remember, 2 times anything is cutting it in half, and 40 is a pretty easy number to cut right in half. 20 and 20. 3, will 3 go into 40 equally? Well, 4 plus 0 is 4, and 3 doesn't go into 4 equally, so skip 3. That don't work. And then 4, yeah, 4 times 10. 5, it will, because this ends in 0, and I know that 5 times 8 is 40. What about 6? It's even, but 4 plus 0 is 4. And remember, 6 had that divisibility rule of it needs to be divisible by 3, and it wasn't. Skip 6. 7, no, I know 7 times 6 is 42, and 7 times 5 is 35. It skips right in between, so that's not going to work. And there I am back at 8 again. Again, finding those factors, at first it's cumbersome. It can be, it can take some time, but as you practice it, it becomes faster and faster. 1 times 32 gives me 32. 2 times, I want to say 16, but I'm not all the way positive. I'll just do a run it real check real quick. 2 goes into 3 once, and 2 goes into 12 6 times. Yeah, it's 2 times 16 that gives me that. Okay, what about 3? 3 plus 2 is 5. 3 doesn't go into 5 evenly, so it's not going into 32 evenly. Skip number 3. 4, 4 times 8 is 32. This is where it was nice to know my multiplication facts, right? It's helpful. 5 won't work because this does not end in a 0 or a 5. 6 times 5 is 30, and 6 times 6 is 36. It skips over it. That's not going to work. 7, no. 7 won't work, and then I'm back at 8 again. Okay, those are all the factors for 32. Let's find all of our factors for 16. We know it's 1 times 16. We know it's 2 times 8. 3 won't work because 1 plus 6 is 7. 3 doesn't divide into 7, so 3 doesn't divide into 16. And we know that 4 times 4 is 16, and of course there we are, back at 4 again, so we can stop. Okay. 1, 2, 4, 5, 8, 10, 20, 40 are the factors of 40. 1, 2, 4, 8, 16, 32 are the factors of 32. And 1, 2, 4, 8, 16 are the factors of 16. So what are our common ones? Well, you heard 1, 1, 1. It's always going to be a common factor. 2, 2, 2 is a common factor. 4, 4, 4 is a common factor between all of them. 5 is not because it wasn't a factor over here. 8, 8 is 8, 8, 8, and that looks like that's it. 10 isn't over here. 16 is here but not here. No 20s, no 40s. Okay, that's it. 8 being the highest, the greatest common factor. They're only asking for common factors. They're not worried yet about what the greatest common factor is, but I'm just giving you a little preview. Usually that's the one you want to go with. So we found that our common factors are 1, 2, 4, and 8. 1, 2, 4, and 8. So she can do rows that have one plant in them and a big long row of them, or big long length of them. She can do rows that have 2 plants in them, and they would have the same amount of, or the same type of plants in each row, and there would be a whole long row of list of them. She can do rows of 4, and she can do rows of 8. Those are her choices. Number 2 just says, what if Lucy has 64 bean plants instead of 40? What if this was 64 instead of 40? What would my common factors be? I have 1 times 64, 2 times 32. I looked at that and did that quickly in my head, because you start getting used to breaking things apart. 2 goes into 6 3 times evenly, and that was what helped my brain be able to find that so fast. And then 2 goes into 4 twice. Sometimes you get to a point where you can just see that happen in your brain. 3, does 3 go into 64? 6 plus 4 is 10. 3 doesn't go into 10 evenly, so it won't go into 64. Will 4 go into it? I don't think so. I'll try it, but I don't think so. 4 goes into 6 once. Oh, it sure does. 4 goes into 24 6 times. So yeah, 4 times 16. 5 won't go into 64 because it doesn't end in 0 or 5. 6 won't go into 64 because 3 didn't go into it, so 6 won't. 7 won't go into 64. 8 times 8 is 64, and then that's where I stop. So if we aren't looking at these common factors anymore, we know that we have the 1 as a common factor with 32 and 16. The 2 is a common factor. The 4 is a common factor. 8 is a common factor. Oh, and look at here, 16 is a common factor. That's now the largest common factor, and that's as big as you're going to get. So 16 would also become a common factor. So on number 2, 16 would also be common if that number had changed. So all this lesson is about matching those common factors up, finding those factors, so you're going to get tons of practice factoring numbers and getting familiar with what factors build a product. And it's good multiplication practice anyway, and then you'll get the practice of matching them up. So it just gives you a lot of practice, and it is a skill that will come in handy, especially as we get into fractions or grouping things. Good luck. We can practice some more in class if it's necessary.